based on the coastal watershed assessment procedure was used in British Columbia as well, but looking at road density, dam density in each watershed, surface water usage, groundwater usage. This is new information that we didn't have before, but we're getting. And we have length of roads within 100 meters of streams, which helps show the pressure on the riparian areas. Proportion of watershed with human land use can inform many different values, but including hydrologic change. There's acid rock drainage risk. So in addition to acid rain, Nova Scotia has acid rock drainage, which basically if you expose a certain type of bedrock, it will release sulfuric acid and drop the pH as well. So we need to know where that is in the province. Number of stream and road crossings, proportion of stream length behind dams, proportion of streams bound by human land use, and this index of acidification. Okay, so that's a lot of information, but this gives you a sense of the type of information we are bringing together. Again, this is in table form, same information, and these watersheds indices, so for example, the number of stream road crossings here, we generated those with a simple GIS watershed model builder, and that's handy because we can just rerun it as we get updated information, and it can be we can change the model parameters for other scenarios. So that's sort of been a useful tool to examine scenarios as well. And so we get maps like these are where the stream road crossings are in the province. And if we just come up with a map of all these points, it's not really that helpful. So we needed a way to sort of agglomerate that into the watershed units to get a sense of where most stream crossings are located. So what we did, this is related to Meredith's talk, like how do you rank watersheds. And so what we've done here is not chosen an independent baseline, but rather just showed a relative ranking of a watershed. So this is showing of all the watershed units, which ones have the most stream crossings and which one has the least. It doesn't say that the most is critically bad or the least is really good, but it's just, at this point, based on the information we have, this is what we can say. And the next step will be to look really at judging how good that is or not. Right, so we used, instead of, we used a relative ranking to compare the watersheds. We used 5 categories, ranking from 1 to 5, right? So fairly simple. And so you remember we had those 11 watershed indicators, right? So we could produce 11 indicator maps. So we can have, for example, groundwater withdrawal. I'll show you some examples now. One is stream length behind dams. So now that we have information on where the dams are, we're able to capture that as part of this process. It's very exciting and a bit depressing because there's watersheds like this where we have 25 to 40% of the stream length behind a dam that is impassable for fish. So that's to learn. And these are all the dams without fish passage requirements. So this has, in turn, has been useful for the SARA procedure, the species risk evaluation for the Atlantic salmon. So just knowing what the threats are in salmon. Another one, it's been interesting. We've had some with the road density ranking. So this is the density of roads within a watershed. Okay, we're seeing some new hotspots that are really useful discussion tools within different sectors. Okay, why is this one the way it is? This isn't what I expected. I expected, yeah, Halifax makes sense, but you know, what are these outliers? And that's really been a really good discussion tool to bring people together. And also, you know, maps like this helps build discussion for maybe we should have a riparian buffer policy for Nova Scotia. Yeah, oh my God, yeah. 5 minutes left. Okay, good. There is not one presently, and you can see this is the proportion of streams bound by human land use, right? So really where that pressure is on the riparian zones. So we can see that we do need a riparian buffer policy for the province. But it can really spur those discussions, so it's good. And another example is for these stream road crossings. It can be useful for providing discussion on where should we be prioritizing culvert assessments, because that's been a big issue as well. There's a lot of culverts as in BC and Alberta that haven't been maintained and can serve as fish passage or erosion hazards. And then another application that's been good is okay, so there's one mitigation option for acidification is catchment liming, basically spreading limestone all over the soils to help buffer the pH of the rain. And these types of maps are helpful for us to decide where we should be doing that. I mean, maybe it's not the best to be doing it where there's already acid rocks, and that if a person digs up and drives it, they'll undo all the pH increase done by the catchment liming. So these maps are going to be a useful tool. And I think that I'm going to keep it under 20 minutes, and I won't go into the values so much, but I'd like to talk about the products, because I thought Meredith's talk was great and what they've been doing in Ontario and with the report cards. And this is really in process, so we've had this 8 months of really frenetic information gathering and seeing where we can take the information, and now we have to step back and make it useful for the public, because the stakeholders, the public really want this information as well. It's not just for the government sector. So we have watershed report cards that we've started, that I fixed those based on what you've been doing, and provincial scale maps, and a geodatabase that is assembling all this information we've been collecting into one spot that will be made available. And we have documentation on the models that we've used and the method pages. So this was our original watershed report cards. And I don't think I'll get too much information. There's been confusion with, I mean, I'm an academic, right? So we need to do more outreach and make it more user-friendly. We were meeting, my colleagues was meeting with the Deputy Minister this week, and that's really our next phase, is to take this academic output that we produced and make it user-friendly. But this is our academic report card, but we have watershed maps and the baseline physical characteristics and scores, the ranking scores on how the watershed is ranked for the different watershed impacts. And we actually went as far as to produce an overall ranking the all watersheds. Yeah. So that's we calculated that, but we were like, oh, we couldn't take that too far. And this is what it is, right? So just exploring what if, right? So if you can rank all the watersheds, and is this helpful? Is this how best to communicate results to stakeholders? Is this map useful? So this is basically adding, very simply assuming equal weight of watershed impact indicators and just seeing which watersheds have the most. And fortunately, the number one watershed is actually where most of the resources are being allocated. So that's good. But the next phase, what we'll be doing is looking at where resources are, conservation measures are being spent, and sort of comparing that to where the problems are, making sure that there is, it's making sense, right? And if there's areas, watersheds showing a very high impact but no conservation measures are there, then that's something that needs to be looked at. It would be interesting to bring up. Right, so as I said, we identified gaps in the data. Watershed boundaries were not accurate, but those are being fixed. Right, so the next steps, and this workshop has been very helpful in helping to refine these ideas for the next step. And in addition to the sub-basin scale watershed assessment, so making the assessments on the smaller spatial scales, we're refining and adding new indices. In addition to water budgets, I like the idea of, based on Hussein's thing, like how citizens make their living, really get that human element to these watershed assessments. And also, based on Margot's talk, I mean, I think looking for ways to bridge this information to the public with human health values, and I'm interested to read what you've got, try and make that link, because I think there's a lot of potential there. Right, so my last two slides here. One is just bringing up the question of resilience. One of the questions when I arrived in Nova Scotia is why do we know so little about water? It's very surprising. One reason is, well, it was the cod and the people had their backs to the land and were looking at the oceans, right? But maybe geography had something to do with it. there's not a lot of downstream effects. There's not a lot of upstream people affecting the downstream here because there's such small watersheds that go to the coast. So if there's a water crisis in this watershed from mismanagement, they don't have to go very far to get the water they need, right? So maybe this has led to a lack of awareness, and perhaps the system is more resilient to a point. But so is that part of the reason why many of these watersheds have been chronically understudied? Possibly. But now we have this Atlantic salmon crisis is one of, as I referred to, with the population really is at a critical point. So does this suggest that we are at a tipping point in the system? I think that we are. So so there is a sense of urgency in really moving this project forward. As I said, I'm not a policy expert, but I'm doing my best to make this project go forward, and it'd be good to get any ideas if you have, or synergies of other projects, similar projects that have been going on in Canada. And it's really a time for opportunities for innovations in watershed management in Nova Scotia, partially because there's pretty much a clean slate. There's not a lot that's already been, you don't have to undo anything, right? So that way it's an opportunity. Okay, but thank you so much.